Voltage rules. To understand voltage in circuits, there are two rules we must know. So voltage in parallel and voltage in series. Yesterday, you guys looked at current in parallel, current in series, and the rules are a little bit different. So what I'm hoping you're going to do is click on these other links, and you can actually see me doing a demonstration with lab equipment of the rule for parallel and the rule for series. Another thing we have to note before we start is how to actually measure the voltage. So your voltmeter has two wires, and you put the wire on both sides of whatever you're trying to measure the voltage of. So this is a lamp, it's just a little circle with a hoop around it, and you put one end on one side, the other on the other. Now, another word for voltage is potential difference. And the reason we call it potential difference is because you're measuring the difference in energy. Okay, potential is energy and the difference. So we want to know, well, how much energy the electrons have going into the light bulb. Obviously, they used up some of that energy, and then how much energy is used or is there when they leave. And the meter actually subtracts two numbers, and that's what we read in volts. Same thing for a battery. When the electrons go into the battery, they've already lost a bunch of their energy going through different parts of the circuit, so they get charged up at the battery, and then when they leave, they're all charged up again. So we do the same thing. So the potential difference is how much energy did I have before, after, and we read that in volts. Anyway, so our rule for parallel is this. In parallel, it doesn't matter how many loads. A load is just something that uses electrical energy you have. Okay, it could be light bulb, could be a toaster, it could be a kettle, it could be anything. Doesn't matter how many you have. If something's hooked up in parallel, it's all going to read the same number. So if this one's 5, this one's 5, this one's also 5, this one's 5, this one's 5. So T is like what happens at the battery. So VT is equal to, so the voltage across the battery is the same as every part of the circuit. In this case here, there's 1, 2, 3, 4 parts, so I would go all the way up to V4. So V1 equals V2 equals V3 equals V4. When we look at in a series circuit, everything, the electrons have to go through here. They have to go through here. They all have to go through here, and then back to the battery. So in the series circuit, they all add to give you the total. So in this case here, there's 4 parts to the circuit. So I would go 3 plus 4 plus 6 plus 5. So the total, or the battery, is 18 volts. That's how much energy there is that the battery has to recharge up the electrons. So the two main rules is in parallel, voltage is the same. Doesn't matter you have 2 of them or 222, they'll all be the same. In series, the battery is equal to the sum of all the individual parts. So you have to add up all these individual ones. And there is a page I want you to try. And similar to the one you did yesterday. So first thing you have to do is tell me, okay, the type of circuit. Well, in the first one, it's a series circuit. And once I know it's a series circuit, I look at my rules for series. There it is. And they add to give you the battery. So in this case here, it's going to be 2 plus 3 is 5. So my answer is 5 volts. And this one here, it's parallel. So in parallel, it doesn't matter if there's 2 or 222, they're all the same. So if that's 5, that means the total of the battery must also be 5 volts. So I want you to go through. Now, where we get a little trickier is when we get, excuse me, to the both circuits. G and H are both series and parallel. These two resistors are in parallel to each other, but this resistor and the battery are in series to each other. So when you get to these both circuits, what you need to do is tackle the parallel part first. Okay, and see how I've drawn a circle around it? So I'm going to redraw my circuit, but I'm going to draw this as a package. So I'm going to draw my battery. There's my 200 volts up top. And instead of a circle, I'm just going to draw it as a box. But what's inside that box? Well, it's my 2 resistors in parallel. And then I come right back to my battery. Well, in parallel, everything's the same. I know that it doesn't matter if there's 2 or 222, they all be the same. So if that one's 120, that one's 120, that means this box must also equal 120 volts. So now I have 200 volts, 120 volts. These two things are clearly in series to each other. They would add up to give me 320 volts across the battery. 320 volts across the battery. So you're going to do something similar to this part of the circuit too. You're going to look at the parallel part first, redraw it as circuit looks exactly the same, but put a box here. What's inside that box? Well, it can be 2 resistors. It can be a toaster. Toaster has a whole bunch of resistors in it. And then you're going to have 3 things. You're going to have 3 volts plus this box, which is going to be 2 volts, plus this resistor, gives you the battery. All right.